In this video we are going to look at using similarity. Shapes are similar if they are enlargements or reductions of each other. What we mean by that is that if a shape has been enlarged or has been made bigger, or if it has been made smaller. But the shapes are only similar if the angles remain unchanged and the sides are enlarged or reduced by some scale factor. Let's have a look at this example here. So here we've got a quadrilateral, here we've got another quadrilateral. And if we just compare the sides, so here's 8, here's 12, 6, 9, 16, 24, 10, 15. If we look carefully, we can spot that this shape is 1.5 or 1.5 times bigger than this shape. 8 times 1.5 is 12. 6 times 1.5 is 9. 16 times 1.5 is 24. 10 times 1.5 is 15. So all the sides have been enlarged by a scale factor of 1.5. If we are asked specifically to calculate the scale factor, how we get the value of 1.5 is from the following. We look at the shape that we are working to. Here we are working to this shape on the right. And how we calculate our scale factor is we look at a new measurement and we divide it by an old measurement. So for example, we can look at 12 centimeters and 8 centimeters. What I mean by that is we can write that as 12 over 8. And if I just bring this over here, 12 over 8, the scale factor can be simplified to 3 over 2, and 3 over 2 is 1.5. So to use our scale factor, we need to be able to apply this formula here to calculate it. So when we are just comparing similar shapes and just lengths, so we're just kind of focusing on lengths at the moment, we need to compare the new size over the old size, and then we can use that to help calculate other missing sides. For example, let's say I did not know this distance here. Let's just imagine for a moment that we didn't know what that was. And let's imagine the question was we wanted to calculate this. Let's say this was called x and we wanted to calculate it. To calculate it, we know that every side has been times by 1.5 to get the corresponding side. So if we want to find out the value of x, if we times 10 by 1.5, we will get the corresponding length of the side x. Okay, that is the general thinking of how this is going to be working for similarity. Okay, let's look at a straightforward example here. We are told in the question that these shapes are mathematically similar. If we see that information given, that means that we need to use the scale factor. That's what we're going to need to be working with. Okay, so we are told that the length is 30 centimeters. The height is 21 centimeters. Here the height is 14 centimeters and the length is x. So we want to calculate the length of x. So here's where we approach these problems. So we want to calculate the scale factor. I'm just going to write SF for short. To calculate the scale factor, we do the new divided by the old to see how we compare them, what we have to multiply to get the corresponding side. So we can only compare sides that have the same value, so we can only compare the heights because we've got lengths for the heights. So we're working towards the shape, that the object that has the letter x, so the new is going to be 14, the old is going to be 21. If you can simplify your scale factor, by all means, both of these can be divided by 7. So here my scale factor is 2/3. On some occasions you'll have fractions that are quite straightforward to work with like this. Other cases it may be more straightforward to convert into a decimal. It is entirely your choice. Personally, I would keep them as fractions. So, I have calculated my scale factor, it's 2/3. I now want to find the value of x. So when I did 21, and if I multiplied that by 2/3, I'm going to get 14. So the exact same is going to happen here. And so to calculate x, I'm going to need to multiply 30 by 2/3. So I'm going to do 30 times 2/3. And if we make this into a fraction problem, that's the same as 30 over 1. Let's see if anything can cancel diagonally. 30 and 1, or 3 and 30, sorry, both can be divided by 3. 10 times 2 is 20. 20 over 1 is 20. So the length of x is 20 centimetres. We're just going to look at one final example when we are using a length scale factor. Okay, in this last video where we're going to be exploring similarity and length, we've got the diagram opposite shows an aluminium pipe frame. The cross members QS and PT are parallel. So both of these are parallel. RS is 48 centimetres, QS is 24 centimetres, PT is 32 centimetres as shown. Calculate the length of ST. So here it might look a wee bit different with respect to we don't have two shapes to be compared. But we actually do, and it just needs to take a wee bit of finding to find them. A wee bit of looking to find them, sorry. If we look very, very closely, we can see that we've got the triangle QRS. I'm just going to do a wee sketch, or RQS. So here's RQS. This is 24 centimetres. This is 48 centimetres. We also have the triangle RPT. RPT. We know that PT is 32 centimetres. Okay, but how do we know that we can use our scale factor? How do we know that we can apply similarity? Remember, we can only do similarity questions if all the angles are the same. So let's have a look at the angles to see if they are the same. Obviously, in the two triangles, this angle will be the same because it's the same angle for both RQRS and PRT. These are both the same size. Okay, let's look. We have got parallel lines here and here. And if we recall back to our angle properties, if we've got a straight line and it's intersected by two parallel lines, it can create an F shape. And in an F shape, these angles are equal. So let's have a look here if we've got any F shapes. We've got this line here and here and here. Okay, so although it's upside down and back to front, we do have an F shape, which means that it means that this angle in here is the same as this angle in here. Okay, so that corresponds to these 2 points here. So far so good. So far I can use these properties, or I can apply it. I just need to check my last one. I've also got an F shape going back here, which implies that these angles are the same. So we know that we've got matching angles. I can apply my scale factor. I can think about my scale factor. What it is that I am looking to calculate is that I am looking to calculate ST, which is part of the big triangle. But in order to do that, I'm going to need to calculate the length of RT in full. And then I can subtract 48 from my answer, and that will give me the value of ST. So what I'm looking for is X here. So we're doing a scale factor. We can use a scale factor because the angles are the same. Scale factor is given by the new over old. I can only compare angles, lengths that are the same, so it's going to be 32 over 24. 32 over 24. That can be simplified, both can be divided by 8. That will give me a scale factor of 4/3. So to calculate x in this sense, I maybe should have labelled it y, because I've labelled this x over here. But if we're to stick with this x just now, I'm just going to work down here. So to calculate x, I'm going to do 48 times my scale factor. 48 times 4 over 3. 48 times 4 over 3, that's the same as 48 over 1 times 4 over 3. 3 goes into that once, 3 goes into that 16 times. So x is going to be 64 centimetres. So I now know that from here to here is 64. So therefore ST is going to be 64 subtract 48. That's going to be 16 centimetres. Okay, so we can see that similarity can come in many different forms, and sometimes you need to do a wee bit of problem solving with it as well. When we're doing similarity questions, we just need to ensure that the angles are the same. Hopefully this was quite helpful for you. Thank you.